Hey everybody, today we're going to go over linear equations and how to find some solutions. But first we're going to review how to graph equations. So the first part is we want to make sure the equation must be in y equals mx plus b form. Now remember from last time, that's called slope intercept form, right? Where the slope is m and the b is the y-intercept. And keep in mind the y-intercept is wherever the graph hits the y-axis. So as long as your equation is in y equals mx plus b form, the second thing you're going to do is plot the b. Remember, b is the y-intercept. And then the third thing is you're going to use the slope to find the direction of the next point. So we're going to use the slope to plot the next point. And then step 4, we connect the dots. Just like back in elementary school or kindergarten, right? So let's say, for example, we had y equals 2x plus 1. So the first thing is we're going to make sure it's in y equals mx plus b form, and we're going to check it. Y equals mx plus b. So there we have it. We have the right form. Here's our m, and here's the b. And then we're going to plot b. Okay, so here's my axis. Okay, here's my x and y axis. And the first thing we're going to do is we're going to plot the value of b, which is the y-intercept. So it's always on the y-axis, and that's our value of 1. So it goes right there. So actually, I'm going to put that in green because that's our second point. Okay. And then we're going to use the slope to plot the next point. Now keep in mind our slope here is 2. Go ahead and put that in fraction form, which any whole number can be put over 1. And remember, this is rise over run. So starting at plot B, point B, we're going to rise 1, 2, go over 1. And that's our next point. So we rose 2 and we ran 1, found our next point. And then the last thing you're going to do is you're going to connect your dots. And that's it. Okay, so this is a reminder, if you can't remember, how to graph an equation as long as we're given the slope-intercept form. Okay, so how can we use that to solve systems by graphing? So our first question is, what is a solution? Well, in order to know what a solution is, we have to know what we're looking at, a system or systems, right? A system is 2 or more linear equations. Okay, so they're going to give you more than one for sure. And secondly, a solution or solving it is the point where the two equations intersect. Now, there's three things that we're really looking at here. We have kind of 2 or 3 instances of this. So we have this line and this line, right? And we see that they hit each other one time right here. So this one has one solution, and it's at a certain point. We'll call it xy because it's a point. Now, what if I had this? I have this equation, and then I have another equation that's the same equation. Now, those two lines intersect at all of the points in the line. So this is what we call infinite solutions, because every single point on the line is another point on the other line. And the last one is, what if I have this and a parallel line to it? These will never intersect, so these have no solutions. Okay, so not every system will have a solution, and sometimes systems have infinite solutions, but most of the time, this is what we're going to be dealing with when we're looking for an intersection of the solution. Okay, so let's just say, for example, they said find the solution for 3x plus y Actually, I'm going to use a different example. Y equals x minus 2 and y equals negative 3x plus 2. So our step 1 is we're going to graph the first one. And so we're going to go back to the steps that we learned up here. Okay, so make sure the equation is in y equals mx plus b form first. So we're looking right here. Is this in y equals mx plus b form? And the answer is yes. Right in front, there's this invisible one. That's our slope. And this is the b value. So in order to graph this, whoops, that wasn't very straight. So in order to graph this, now that we've made sure that this is the right form, now we're going to graph the b value first. We can't graph a slope first because we have to have a starting point. So I'm going to do this in pink. The b value is negative 2. We know that's the y-axis, so we go down to negative 1, negative 2, and that's our point. From there, we're going to use our slope, which if our slope is 1, we put that as a fraction. It's 1 over 1. So we're going to go up 1 over 1, and that's our next point. And now we connect the dots. Okay, and that is our first line. Okay, so now we're going to go ahead and graph the second line. So again, we have to make sure, is this in y equals mx plus b form? And it is. Now we have to graph the b value, which is positive 2. So we go to y equals positive 2, and we put our point there. Now we use our slope. Our slope is negative 3. We're going to write that as a fraction. And remember, this goes rise over run. Now, how do we rise a negative 3? Well, remember, a negative just means we're going to go down. So we're going to go here. We're going to go down 1, 2, 3. We're going to go over 1. And look at that. It ends up at the same place as that orange dot that we had before. And now we're going to connect our dots. Okay, so look at that. Did we intersect at the same point? Yeah, so what's our solution? Remember, the solution is the intersection. So our intersection is this point at 1, negative 1, and that is our solution. So our solution is this point right here. Okay, so that's how we find a solution by graphing. How would we solve a solution by substitution? So this is obviously when we're not graphing and they don't have a picture for me. Okay, so for example, we would basically use this process when we see one of the variables by itself. Okay, so substitution is useful only when we see one variable is by itself. So for example, if they gave me this system of equations, whoops. Did it again. 5x plus 7 and 3x plus y equals -9. So again, substitution is only helpful when one variable is by itself. And we actually see that right here. So because we see the y by itself, we know we can use substitution. Now, just like when you have a substitute teacher, another teacher replaces the regular teacher, right? Well, what we're saying is here is this value for y is equivalent to 5x plus 7. So we're going to substitute y for x, 5x equals plus 7, 5x plus 7, every time I see y in the other equation. So we're going to substitute the variable for its expression into the other equation. Okay, so here's what that means. Whenever I see a y in the other equation, I'm going to replace the y with its expression that it equals. So instead of 3x plus y equals -9, I'm going to say 3x plus, not y, but 5x plus 7 equals -9. Okay, so that's our substitution step. And now we're just going to solve for whatever variable is left. So we're going to solve for the variable that's left, that's x. So I'm rewriting this 3x plus 5x plus 7 equals -9. Well, I know 3x and 5x is 8x plus 7 equals -9. Solve for x. We're going to subtract the 7. And we get -16. Divide both sides by -8. And we end up with x equals -2. Now, we just found x. But remember, we want a solution, aka a point. And a point has two parts. It has an x part and a y part. And then, once we solve for that variable, we're going to plug back in to solve for the other. So we're going to take that x and we're going to plug it back in to the original y that we used. So we know y equals 5 times x, which is really -2 plus 7. And we got that from right here. So we get y equals -10 plus 7, which is -3. So if that's our y, our solution is x comma y, which is -2 comma -3. And make sure that your solution is in an ordered pair. Okay, so how do we solve by elimination? So elimination, we can use addition, subtraction, or multiplication. So let's first use, let's talk about what elimination means. Elimination means that we can, you may not have something by itself, okay, but that we want to cancel two terms that are alike in each equation. So for example, if I have 5x minus y equals 8 and -5x plus 4y equals -17, and I wanted to solve this equation, meaning finding the solution, I'm going to look what I have. Basically, when I'm solving by elimination, I'm looking for what is alike in some way. Well, I can see 5x and -5x are very alike. They're opposites of each other, right? So what I'm going to do, because I know that they'll cancel each other, I'm going to add them. So when I add the top equation to the bottom equation, it's going to cancel out. So 5x plus a -5x gives me 0x. Basically, they cancel out. -y plus 4y gives me a total, remember there's that invisible 1, we have a positive 3y left. And positive 8 plus negative 17 is a negative 9. Well, I know 0x is just 0, so that's 3y equals negative 9. Now we're going to solve for the variable. We're going to divide by both sides, and we get y equals negative 3. But again, we need a value for x and for y. Once we get y, now we're going to plug back into an original equation. To get the other variable. So here we go. I'm just going to pick this top one. I know 5x minus 1 times y, which is negative 3, equals 8. So that comes from 5x minus y equals 8. Okay? We plugged in that value of y right here. And now we're just going to simplify. 5x minus 1 times negative 3 is positive 3 equals 8. We're going to go ahead and subtract both sides. We get 5x equals 5. Well, that's pretty easy. Divide both sides by 5, and we get x equals 1. Write our answer as an ordered pair, 1 comma negative 3, and we're done. Okay, so that's when you're going to use elimination, when we're looking for something that is alike enough that we can cancel them out. Okay, so what if you have one that's like this? What if you have one that's like x minus 2y equals negative 7 and 3x minus y equals 4? So we don't really have anything alike per se, but when we don't have them alike, so if we don't have them alike, we can make it. So I'm going to pick something, and I'm just going to go ahead and say, well, I could either make the x's alike or the y's alike. We're just going to choose, and sometimes it's not an easier choice, but we're going to choose what would be easy. To get alike. So I'm going to choose by multiplying this top one by a negative 3, and here's why. I see that this is a 3x. If I multiply everything on top by a negative 3, I'll get negative 3x and positive 3x, which are really easy to cancel. So I'm going to multiply this through and write it right underneath. So minus 3x, negative 3 times negative 2 is positive 6y, negative 3 times negative 21 is positive 21. So I'm going to write a line under this top one now. So now these are my two equations. Can I eliminate those? And the answer is yes, just like the last one. 3x minus 3x, cancel, it's just 0x. Minus y plus 6y is 5y, equals 4 plus 2, or 21 is 25. So all I did was I basically added these two equations, and this is what I've got. Now we're going to solve for y. We get y equals 5. Great, but we're not done, right? So once we chose what was easy, then we did what we learned before, which was the eliminate. And then you plug back in, which we found y. And then now you take that solution and you plug it in again. Okay, actually, we only plug back in once. So we just eliminated. Now we're going to plug it back in to, if y equals 5, we're going to plug it into one of the equations. I'm just going to use this original equation here into x minus 2y equals negative 7. Remember, y we found was 5. So x minus 2 times 5 equals negative 7. And now we can find x. So we've got x equals 3, and that solution is 3, 5 in an ordered pair.